Hey guys, and welcome to this Gradle Kotlin beginner crash course, in which I will really go over all those aspects of Gradle that you definitely need to know about as an Android developer, because Gradle is something where you can't work without that as an Android developer. It's just needed for each and every project, or at least in 99% of the projects. At the same time, Gradle, I feel like, is the number one source of issues and error messages that people get in their projects, and I feel like most of these could be solved by just understanding Gradle better. And I do already have a similar video where I go over Gradle features, about what you need to know about Gradle for Android projects. But that video is 2 or 3 years old. It was about Gradle Groovy, and since then just a lot of things changed. So nowadays we use Gradle Kotlin, we use version catalogs, which are the default here in Android Studio. So a few things just changed, and I think especially if you're a beginner, then the older video might confuse you, which is why I decided to make a new dedicated crash course on that. So you can just spend these 30, 40, 50 minutes, I don't know how long this video will be, you can spend that just once, and you'll probably understand more about Gradle than I think most average Android developers. And by the way, PL Coding Black Week has just started, so that means for the next week, starting from today, when this video comes online, you can get up to 30% discount on all my premium courses and bundles, even on the already discounted ones. So check it out. The discount will be automatically applied in checkout. It will last for 1 week until next week Sunday. And also, if you maybe missed joining the Mobile Dev Campus when it launched a month ago, you now have a unique chance to join it again for the launch offer. There are already over 300 members in this community, all Kotlin multi-platform native Android developers who are all super active, who exchange about mobile development topics, who learn from each other, who all participate in the monthly app dev challenges where you get Figma mockups, where you get requirements. So you really get everything you need on your roadmap to becoming an industry-ready developer. You'll find both the courses and the campus by clicking the first link down below. As I said, discount will automatically be applied. Happy learning. So when you open up a new blank Android Studio project, that is at least what I did here, then the project structure will already reveal the name Gradle a lot of times. So you can see this Gradle folder here. We can see we have build.gradle.kts. In our application folder, we also have a build.gradle.kts. We have a Gradle properties, Gradle W, Gradle.bat. We have a settings Gradle.kts. So it seems like Gradle plays a pretty major role in Android projects. But before we dive into all those files and understand what these are for, of course, first have to understand what Gradle is actually used for. And the short answer is, Gradle is really just a task runner. So that means Gradle runs the right tasks in the right order to achieve a certain result. For example, to make your app runnable, to install it on a device, and finally see something on the screen. Because we can't just type our Kotlin code in a Kotlin file and then compile that and suddenly run this on an Android device. No, there are actually a lot of intermediate steps that actually have to happen in the right order to be able to take such Kotlin code and finally execute that on an actual Android device. Because what this requires is things like, first of all, downloading all your dependencies and library versions that you might want to include in your project, since these are obviously not included in your folder by default, but these have to first be downloaded from some kind of remote repository. Then maybe it includes a step for linting, where all your code conventions and such things are checked. It obviously has to compile your code, but also package all those files together in an APK file that can actually be installed on an Android device. So all your app's resources, the strings, the actual Kotlin files, of course. Gradle is responsible for example, for signing your app. So if you want to publish that to Google Play, it has to be signed, otherwise you won't be able to publish it. Gradle is then responsible, for example, to also launch the app on your device, like first install it and then launch it. And it's important to understand that it's actually not Gradle that brings all that functionality with it. That Gradle knows how to really communicate to an Android device and install an APK on it. But Gradle is what uses the tools that know how to do that. So in that case, for example, ADB, which is the Android debug bridge that ships with Android Studio, and is really just the API between Android Studio and your device, which allows you to change certain settings of your device, to install apps on it, to uninstall apps. And it's really just a command line tool, which Gradle in this case makes use of. So you can really think of Gradle like a conductor in an orchestra, which says, okay, you guys first, then you two guys can actually run in parallel. You can make music at the same time, and in the end, we get a nice song. That is really what Gradle is about. And it's also not strictly coupled to Android. Android just uses Gradle, but you can also make use of Gradle as a build system for things like plain Kotlin projects, for other types of programming languages. So Gradle is really just a standalone system that allows you to run specific tasks in the right order. That's really all about it. Then I want to lose a few words on Gradle Groovy versus Gradle Kotlin, which I've also highlighted a little bit. So my previous video that I made on YouTube was about Gradle Groovy. So that was the more old version of Gradle, which has a different syntax, just slightly different. But then there's also this newer Gradle Kotlin, which uses Kotlin as a programming language, so we can define our actual build logic in our favorite language. And in the end, both Gradle Groovy and Kotlin are used to do the same things. And they also can mostly do the same things, but the differences are just in the language that we use. With Gradle Kotlin, we get things like type safety, and it's just much more convenient to also build certain extensions for our build process since we can code these in Kotlin. So let's next actually go through all those Gradle files that Android Studio gives us here for a plain new project. Just make sure you are actually here in the project view and not Android, because in Android, certain files will be hidden. You can see it actually bundles all the Gradle related logic here. Let's actually stay there. I think this makes it easier, except for one, and that is the Gradle Wrapper. So the Gradle Wrapper is not included here, but if we switch to the project, it is there in this Gradle folder. You can see we have the wrapper here, and we also have this Gradle W, so Gradle Wrapper executable. This is an executable that you will eventually have to work with. So typically it just gives you the command line access to Gradle functionality. And if we go to our command line or terminal here, and we type /Gradle W, then we can, for example, list all the tasks that Gradle knows in the context of our project. So if we hit enter here, then you can see something happens. Gradle will do something. And then we get this output. So those are all the tasks, all those green things here that Gradle could execute in the context of a project. So you can see how many single tasks there are actually possibly necessary in order to achieve what we want to achieve, like build an app, like run an app. You can see there are tasks like clean, which just delete the build directory. So with all the files that relate to a specific build. So when I say build, that is really just what Gradle has done after packaging everything together. You can see there are specific tasks for compiling the Android test sources. So if you have an Android test, an instrumented test that runs on an Android device, then there is a task to compile that for the debug variant. That's also something I will get to more in this video, what these debug release variants are, what a variant is in the first place. If we take a look here, you can see we can display all the dependencies that Gradle knows, so all of our libraries. We have install tasks to install something here on our Android device, to uninstall something. We can run certain checks, so that is interesting for linting. We have a lint-specific tasks to fix something, to lint just the release build, the debug build. We can run our test cases from Gradle. You can see there are a lot of these single tasks that Gradle knows, and the moment we click run here, Gradle will just go through all the tasks that it needs to run in order to really build our app, install it on a device, and run it that are just necessary for that. And it will do that in the right order while maximizing efficiency by possibly running certain tasks in parallel that don't depend on each other. So that is what the Gradle Wrapper does. It's simply a command line interface you can use to execute Gradle tasks from the command line. What's then interesting is, if we switch to the Android view again, then we have this build.gradle file for the project, and we have this build.gradle file for the module app. When someone refers to the project build.gradle file, they mean this one. So let's open this. And you can see this is really just a top-level build file where we can add configurations that really apply to our whole project. For example, plugins. So Gradle works with these so-called plugins, which are really just Kotlin classes in Gradle Kotlin that encapsulate build logic. For example, a plugin that configures our Android application module, or a plugin that is used for Jetpack Compose, because Jetpack Compose comes with a compiler, which has to change and adjust our Jetpack Compose code a little bit so that it's optimized, that it definitely runs. And that has to happen automatically. And the logic for this is just encoded in this Kotlin Compose plugin. And really just to give you an impression of this, a plugin is super simple. Let's actually apply this here in module app. I will say something in a moment why these say apply false, but here in our plugins block in the build.gradle app, we also apply these plugins. So we actually make these run. But what we could do is we could just define our own plugin here. Let's make this a Hello World plugin, for example. It would need to implement plugin from Gradle API, which would come with a project. So I will also say something about what a Gradle project is in a moment. But here we would then need to override this apply function, which gets triggered when we apply this plugin in some kind of Gradle file. And we can then print something like Hello World. And if we then go to our Gradle script and we say, we apply a plugin, take this function that does not take any parameters, and we pass in our Hello World plugin, then the moment we click sync and actually take a look in our build output, which is here, we get our hello world statement, because we've encapsulated certain logic in our custom plugin, which we've then applied in a specific Gradle file. So this is really all a plugin is about. It just has this single entry point, this apply function, and when we apply it in a certain module, here we then encode what this plugin should actually do. Like, for example, transform our Jetpack Compose code. That would be a really advanced plugin. But it could also be something as simple as just configuring your room setup for a room database, like setting the schema directory and just the build-related configuration for a specific library. That is something you could encode in a plugin and then reuse across modules. That's something I'll also say something about in a moment. But for now, it's really just important to understand that a plugin is nothing else than a Kotlin class. Let's get rid of that again. Let's get back to the plugins here that we get from this alias, where we say apply false. Why don't we want to apply that? And here for the plugins in our build.gradle app, we don't really apply these, or we at least don't have this apply false or apply true here. Well, first of all, to understand what a Gradle project is. You can see we have this project level Gradle file. A Gradle project is really just what Gradle sees as an isolated system in which it can run its tabs. This does not always necessarily refer to a single Android Studio project. In most cases, it is like that, but you can also define certain sub-projects in your Android Studio project. But that is more advanced. That's something I go over in my Android Essentials bundle. Link that down below, where we really configure a larger multi-module app in Android. But for now, you can think of a project in Gradle just as a project in Android Studio. So logic we would apply here in the project level Gradle file would apply to the whole project, and logic we then apply here in this app level Gradle file will just apply to this application module. The thing is, the way how Gradle works when we want to apply certain plugins is that we first need to put them on the so-called class path. So that is pretty much just like declaring a dependency in Android, where we just say, hey, this is where you get this dependency from. This is where you get the plugin from, because each plugin has an ID, which Gradle can use to just fetch information about it. But we don't want to run these plugins yet at an application level, which is why we don't apply these. So as long as you don't want that, you would always have to add this apply false here in this plugins block in the project level Gradle file. However, in our specific module, which comes with a lot more config, like all of our Android related build config, I'll go over that in a moment. But here, we now want to explicitly apply those plugins. And if we actually omit this apply true, then it will be applied the moment we specify the plugin here. And applying a plugin really just means calling this apply function that I just showed you in our Hello World plugin. But let's actually go through the rest of this build.gradle app file so you also understand what this is for. So we do have this typical Android block, which obviously only applies to Android projects, where we have a namespace. This is typically just the package name of this module. We do have a compile SDK. So this is the specific Android version your Android code should compile to. So if the version 34, the API level 34, would, for example, introduce certain features, then by setting the compile SDK to that version means you would actually want to make use of these new features in your Android build. Then we have some default config. You can see the application ID is actually the same as the namespace. This is an attribute that is used for the Google Play Console if you publish your app to actually identify your app. So this has to stay the same. If you would publish your app and you would change this application ID after having published it, then a new update would result in a completely new app. So you wouldn't update the previous app because Google Play Console sees that as a new one. So just make sure to keep this the same. Then we have a minimum SDK, so that's just the minimum API level your app should run on. We have a target SDK, which encodes the SDK level, the API level of Android, where you as the developer say, okay, the features this API level brings, and of course all the features below that, I actually tested my app for that and it works. So this is really the highest SDK level where your app is intended to run on, where your app is intended to make use of these features of that API level. We have the version code, which is used for Google Play Console, again, to detect if this specific build is an update. So whenever you actually publish an update to Google Play, you would need to increase this by at least 1. You have a version name, which is really just a human-readable version name. You could choose anything there. You have a test instrumentation runner, so a class that is used to run your instrumented tests. That's not super relevant here if you're not into testing yet. We have those build types, which I will put more towards the end of the video. We have compile options. Also here, you just specify how your app is actually or should actually be compiled, like things like the Java version. things like Kotlin-specific compile options where you specify the JVM version your Kotlin code should compile to. We have certain build features, for example, for Compose, we need to enable that. And of course, a lot more. So that's really just the default config. If you just type this here, then you get access to all those fields and functionalities that you could make use of here in your Gradle file. So you're very free in extending that if you have to. But for starting out, you're fine with this default config. And down here, very important, you probably already dealt with that if you have built certain Android apps yet, you have the dependencies block. So the specific libraries that you want to include in your project, which all come from the so-called version catalog. Since libraries always come with a specific source, so kind of an identifier where these can be fetched from, they come with a specific version that has to be updated regularly. And since this version can often also be reused across different libraries, because of that, the way Gradle manages this nowadays is with a version catalog, which you can find in libsversions.toml. So this is really just a file where you specify all your library versions under this version tag or this version section, where you then specify all your actual libraries. For example, JUnit for testing, where you say, okay, the group of that library is JUnit, the name is JUnit as well, and it should use the JUnit version that we've declared up here. And lastly, down below, you can specify Gradle plugins, which always have an ID. For example, Android application, here for the Compose compiler, and also a version that you can then update from a central place here in the version catalog. I have a dedicated separate video about version catalogs, but it's just important to understand where these implementation blah, blah, blah here come from. So these fields, these come from the version catalog that is located in the Gradle folder. So in the Android view, you see it here, but in the project view, it's actually here under Gradle, libs versions toml. Okay, but when we are already at libraries, what actually is a library? A library is actually nothing else than a module. And a module is what we can also create in our code base. That will probably also make clearer what these single Gradle files will be useful for. But let's go to our project, right-click, and create a new module. You can see we have lots of templates here. So we have Android libraries, and there you also have the name library again. And we have Java or Kotlin libraries. So depending on what kind of logic your module contains, your library, if it's really just a pure Kotlin library and doesn't need to make use of any Android functionality, you would want to prefer a Kotlin library. And if you need to access the Android SDK, so things like the context, activities, broadcast receivers, then you need to make that an Android library. But don't be confused by the term library here, because most developers, especially beginners, know libraries only as kind of extra functionalities you fetch from somewhere on the internet and then you magically have it in your project. But what's behind such a library is really just a module that we create like this. So we have an Android library, and that Android library adds certain functionality to our project. For example, I don't know, imagine you are building a music player app and you have a library that adds streaming related functionality, how you can just stream certain songs. If we then call this module, so again, module equals library, at least in the simplified definition, if we then click finish, then you can see Gradle will actually synchronize your project because you now changed something about your project that Gradle needs to know about, that Gradle has to configure as well. And you'll see what I mean in a moment. You can see it's now indexing again, and after that, we should be good. Because now we have this streaming library here. And if we open the streaming folder, you will notice we again got another build.gradle file here. And also if we switch to the Android view, then we have 3 Gradle files now, because every single module, every single library on Android comes with its own Gradle file. And if we open the streaming Gradle file, then you can find very comparable config to what we have here for our application level Gradle file. But the streaming Gradle file is now used to configure just our streaming module, our streaming library. Because it could now, of course, be that our streaming functionality requires a different minimum SDK than our actual Android app. It could be that we say our streaming functionality uses some kind of fancy newer API that actually requires a minimum SDK of 30. So we could update that here, and it would not have an impact on our actual app module until we make use of this streaming module, of the streaming library, and actually include it in our application, application module. So by default, the code that we specify here in streaming would not be accessible in our Android module, in our main activity, for example, because this is really to be seen as an isolated container of code that adds all the functionality another isolated container of code would want to make use of to add certain streaming functionality to their app. So by default, if we go to streaming, Kotlin Java, and have some kind of test class in here, and go to main, actually Android, open up our main activity, then in here we would not have access to this test class that we've just created, because we're talking about different isolated modules. And by default, the app module has no influence or has no access to the streaming module, the streaming library, because we did not implement that yet. And that again works via Gradle. You guessed it. So we again go down to dependencies. A dependency really isn't just such a string, which is hidden behind this here in version catalogs. So the typical implementation, com n.x core, blah, 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 specifying the version. That is the case if you want to actually include such a module, such a library from a remote data source, from a remote repository, because that's what all the library authors here did for the common libraries like n.x core, for things like retrofit, ktor. All these are actually published somewhere online where apps like these can fetch and download these and include the actual library source files in this project, so you can then make use of that. But if we now go to our app module, what we could also do is we could say we want to implement our own library. So implementation, and the way this works is with project : streaming. So this is how we add a library notation that comes from our own project. If we synchronize this and then go back to our main activity, type test, we suddenly have access to our test class that comes from our own kind of library. We do have that library local in our project, so other people couldn't easily get that same library in their project unless we export it in some way or also publish it to some kind of repository. But this, of course, helps us to isolate certain parts of our code, reuse these across projects, and just include these parts of the code as if it was a normal library. But multi-module architecture, that's how we call it, is really a whole topic on its own, which is why I have this 23-hour course bundle, the Android Essentials bundle. But at this point, in the context of Gradle, it's just important to understand that Gradle is also responsible for managing which library, which module is actually included where, and to also be able to configure every single module in its very own unique way. Because the streaming module now would very likely need different dependencies, different libraries than our application module, because here we work with completely different functionality. And all this is, again, what Gradle manages for us. And the more your project grows, the more such modules it actually gets, the more complicated managing the build logic can actually be, as you might guess. Because there will be a lot of this logic and configuration that will actually be the same between modules, but there will also be logic that is unique to certain modules. And Gradle just allows us to really have our kind of own build-specific code base, where we have our own build-specific utility functionality and configuration that we can freely apply across our project, across all of our libraries and modules. If you're curious where Gradle actually does the link, whether something is a normal folder or an actual module, that happens in the settings Gradle KTS, which you can open here. So here on the one hand, we specify certain repositories, so just remote containers where Gradle will look for libraries and dependencies. On the one hand for Gradle Plugins, but also for normal dependencies. So for example, Maven Central is a very popular one, or the Google repository. But if we scroll down, you will notice that for each module that we have in our code, Gradle added such an include function here. So we have an application module and we have our streaming module. If we would remove this include streaming here, then our library icon here would suddenly turn into a normal folder. And Gradle would also not be able to add this to any other module anymore. Okay, I think this topic around multiple modules, libraries, how Gradle manages these dependencies, I think that's clear at this point. What's not clear yet is, if we take a look in our application Gradle file, and we take a look at those build types, for example, because that's really also a core responsibility of Gradle, that it allows us to manage different build types. A build type in the end is really just a specific stage where your app is currently in the development lifecycle. So the two default build types are debug and release, where debug is just the typical build type you use during development, where you just have different build configuration, for example, compared to when you release your app. The most typical example here is this minify enabled. If you switch this setting to true for the release build, which you typically want to do just for the release build, so what Gradle will do is it will make use of a tool called R8 and obfuscate your source code with that. So what obfuscating means is it will go over all your classes, files, and functions and take all the names of these classes, functions, files and transform these to very short and super unreadable class, function, file names. The reason it does that is that if someone actually gets your APK from Google Play, for example, and tries to reverse engineer that, so tries to get back the source code, all they will see is super hard to understand source code. So they won't really see the code that you see here in main activity, where they can immediately spot maybe certain security issues or certain places where they could manipulate the functionality, but they would just see something like A, B, C, and so on. So it will be much harder to actually understand the source code based on that. And this setting you typically don't want to have set to true for the debug build during development, because this often just takes extra time doing building, and it will also obviously make things like stack traces much harder to understand, since for these stack traces, the class names will also be obfuscated by default if you don't provide a file to deobfuscate that again. And that is why you could also specify your debug build type here, where you say, okay, is minify enabled is actually false. And if we synchronize this and let Gradle apply this config, and then go to build, select build variant, this is the place now where you can define in which variant, so debug or release, you want to build your app in. So by default, it's debug. So if you now run our app, it will not obfuscate our code, since isMinify enabled is false for the debug build. However, if we switch this to the release build, then if we now build our app and if we install it, it will use this config instead. And this is, of course, now also the build you would need to build with when you would want to publish the app to Google Play. So for this build, minify enabled would be true. But you can also define your very own build type. So a typical common extra build type that is not included here by default is called staging. So while debug is just for development purposes and release is when your app is ready to be released, there's often still kind of an intermediate phase where you say, okay, the app is actually ready to be released, but it's still in kind of a testing phase. We still need to send this to our testing team, let the testers go through it. And if you need extra functionality for the testing team, then you could say, you simply create a staging build. And then in here, you would have extra staging functionality. So for example, you could say, isMinify enabled is true here, but you have some extra config that maybe enables some debug UI or so that your testers have an easier life, which you of course would not want to show for the release build. If we would now synchronize this again and take a look at our active build variant, then suddenly staging also appears here because we created that new build type. Another common thing you can do with build types is you can define so-called build config fields. So those are just primitive fields that you can access in your code that still might differ depending on the build type. So you can say, I'm declaring a string here. The name is, for example, base URL. That's a common example. And you can say, I actually have a base URL for the API I'm talking to, which is maybe a UAT URL, so a user acceptance testing, where you just have a special server just for test purposes. And then you have a live server, which you of course only want to use for release purposes, for the release build. So what you can do is, you can say HTTPS, for example, UAT, PL coding, I don't know, this doesn't exist. And it's also important to put this in quotes here, like this. And then we can define this field for each and every build type that we have. So here's staging again. Let's say for staging, we also use the test server, but for the release build, we actually want to use our live servers. I don't know if that was our base URL. In addition, if we would want to use this build config, we need to go to build features, enable that. Build config is true, just like for compose. If we now synchronize this, and probably also rebuild this by going to rebuild project, then we do get some issue here because it wanted the compiler SDK35, but that shouldn't matter. What I want to show you is if we go to main activity, and here we actually refer to build config. This is now a class that was generated by Gradle. Then we do have this base URL field here. And the cool thing is now that if we use this for our API in our project, in our actual source code, that Gradle will take care of giving this field the right value for the right build type. So if we build our debug variant by selecting debug here, then the build config field will automatically be our test server in the code. And if we switch this back to the release build, then Gradle will take care of actually using the live URL for that, without us actually having some sort of check in our code to check which specific build type we're on. So that's also one job of Gradle, to actually manage these different build types. If we go back here, then yeah, that is how you define build config fields with these build types. But that's still not it. Another core concept of Gradle are so-called product flavors. So while build types actually specify the stage of our app in the development lifecycle, so development, testing, release, what product flavors are now used for is to help Gradle differentiate between different versions of our app. So if one version of our app is, for example, meant for audience A and another version of our app is meant for audience B, then we can do that with product flavors. So the most common example here is if your app has a free and a paid version. Then the free version would obviously have less functionality than the paid version. So what we can do is we can go here in our Android block. We can define this product flavors block. And in here we can then again create our product flavors just like we created our build variant, a build type here. For example, a free version. And we might have a paid version of our app. And in here we could then configure similar things as we did for the build type. So we can also specify different build config fields for those two types. But we could also do something like like setting an application ID suffix. For example, .free. And for the paid version, we say it's paid. So this will then simply be appended to our application ID and can be used to identify which specific product flavor an APK is running on. What's also very important is that we make use of a so-called flavor dimension. So what we can do, what I mean with that is, we can say flavor dimensions plus equals the paid status, for example. And that way, what we can do is we can assign this version here, paid status, as well as here. If we give both these flavors the same flavor dimension, it's actually dimension, not version, sorry. We give both these flavors the same dimension, that means they are kind of linked. So our APK that way could be either free or paid. That is because they share the same dimension. However, that does not stop us from defining more product flavors. So if we have more different variants of our app, so another common thing would be if you have certain different variants of your APK, which differ in style, which have a different look. So that's important, for example, if you're building a white label food delivery app, where all these apps definitely need to deliver certain foods and allow a user to order something, but the actual look of that is implemented in a way that it can be easily adjusted to a company's branding. So you can have a branding A, which you then use to sell this app to food delivery company A, and branding B, which allows you to sell this to a food delivery company B. I don't know. So if you just have different styles based on the APK, but the core functionality is the same, you can also make use of that, of product flavors. And you can say, okay, actually, I don't know, you have a green style, for example, and you have a red style. In this case, you would not just add one flavor dimension, but a list of flavor dimensions where the second one would be the style. And then you can say, okay, here the dimension is equal to style, just like here. And that way, we've linked those we've linked those product flavors, and we've linked those product flavors. But if we have product flavors from different dimensions, so one of these and one of these, we can certainly combine these. So there might be a free version of our app in green, as well as there might be a paid version of our app in red. But what's not possible is that we have a free paid version, because these are the same dimension, and there's also not a green-red version. So we can only combine product flavors that have different dimensions. But we can not only combine different product flavors, but we can combine product flavors together with our build types. So we might have a free green variant of our app in the debug build, or we might have a red paid version for the release build. And this combination of build types and optional product flavors, so you don't have to have product flavors, but if you do have these, the combination of build types and the product flavors, that is what we consider the build variant. And if we synchronize this, we can see all of our build variants here under our build variants. So you can see we now can't just build our debug build, because that does not tell Android Studio or Gradle which specific variant I want to build. So whether I want to build the green one, the free one, paid red, I don't know. So here under active build variants, we now have a lot more options for all those combinations that Gradle can actually do between the product flavors, one for each dimension, and our build types. So I think we have 12 different combinations here that we can make out of these different variants here. So you can see we could have a free red debug variant. We can have a paid green debug, a paid red staging. And all this, again, is what Gradle will manage for you. And the last thing that you now need to understand together with all this are so-called source sets. And for that, I will actually remove this style product flavor to not overcomplicate things, synchronize this again. But now I would like to go give you an introduction into source sets, because a source set is something you've already seen if you've created an Android Studio project. If you open this Kotlin plus Java folder, it says no variants found for app. Oh, actually did not remove this style from here. Let's quickly do this. Try this again, and we can also actually bump up the compile and target SDK so we get rid of the issue, the build issue that that we've seen before. But what I wanted to say is, in the Kotlin Java package, we have 3 COM packages where each of these packages is considered its own so-called source set. And a source set is really nothing else than a folder where Gradle looks for code and resources. So you can see all of those source sets here contain some sort of code. Here in this one, this is considered the main source set. We just find our actual application code, but we also have an Android test and a test source set. The test source set will contain all the code that is needed for our test cases, but that code certainly does not need to be part of our main application code, since it's really just used to run our tests. And the same we have for Android tests. So those tests that have to run on an actual Android device, they have a separate source set. And the classes we created here, so if we again have a hello class in our Android test source set, then we can certainly access this hello class in this Android test source set. Here in the example instrument test, for example, we have this hello class, but we're not able to actually access this in our main activity because our main activity does not need to know test-specific logic. So here we don't have this hello. However, the other way around it works. So if we have something in our main source set, which is really meant to be the source set that is accessible to all source sets, if we have something like just a normal class. Hello world. If we have a hello world class and we go to our Android test source set, here we will now be able to access this hello world class, since both Android test and test are just used to extend our main source set with possible more functionality that is just needed in Android tests and tests. So all of our source sets have access to our main source set. That's already important to understand. However, these are really just the default source sets. What we can now do with Gradle is, let's actually switch to the project view, go to our application module. You can see here, you also see this name main. And if we create a new folder here, then Gradle will actually hint us to create certain source sets to extend our existing ones. And you can already see that we could, for example, create a source Android test free Kotlin. So what this source set would contain is Android tests for our free variant. Or if we scroll a little bit, we probably also have an Android test paid. Actually not, because we're not in that build variant. So whenever you want to add a source set like that, you would need to switch the build variant by going to build variant again, and then selecting paid debug, for example. And then if we try this again and create a folder in here, we can have a paid debug source set, or for example, just a paid source set that should also be available. So the source paid Kotlin, here we now have a source set, a new paid source set, which contains just the code for our paid variant. And if we have a source set with just the code for our paid variant, then we certainly also need one with the code for our free variant. So what we can do is we can create a class in here and say, demo text or paid text. Make this a file, composable, call this paid text. And we have a text that says, you're a paid user, because this paid text is really just included in our paid variant. And if we now switch our build variant again to our free debug, for example, then you can see now it's not marked, that the paid one is not marked as an actual source set anymore because it's not applicable for the current build variant, but it's still there and will be used for the paid variant. But if we now go in here and say we have a free source set, so the source free Kotlin, and we also add this paid text over here, where we then say you're a free user. If we then go to main Java, main activity, here where we have our compose code, and we actually have something like a box, for example, to center this, modifier fill max size, give this a content alignment of center. And then we have our paid text, which is now available here. Need to import that. If we run this here with this run button, just normally take a look at our running devices, get rid of that one. This is the one I run this on. Then you can see that's a typical Gradle issue, which I forgot about. But obviously, if we include our streaming module, then we can't add a module that has a higher minimum SDK than the actual app that we want to run this on. So we would need to revert this, or actually not add this module to our app module here. Let's actually just get rid of that, synchronize this, and then we can relaunch the app, and hopefully I can show you what I want to show you. Relaunch this. There's our main activity. Here we are. There we go. And it says you're a free user. Why does it say that? Well, because we are on the free build variant. So if we select the build variant, can I not minimize this? No. You can see we are on free debug. If we switch this to paid debug and relaunch this, and then take a look here at Gradle, then suddenly it says you are a paid user, because we made use of these source sets by just declaring different files that are applied in different scenarios for different product flavors or for different build types. So what you might also want to have is, as I said, a certain debug or test UI, which you just want to display for the debug build. So what you would do in that case is you would again go to app, create a new folder, and you would create a debug source set. So you would have source debug Kotlin, and all the classes that come in here will just be applied by Gradle and just be merged into your real source code for the debug build. If you have this, then you also definitely need to have the source set for your staging and your release build if you're working with these two. And then also declare the equivalent code, how the logic should be for these different builds. So you can always see the main source set as the place that defines the logic that is the same across all source sets, that all source sets, or that is rather independent of a specific build variant. And if you have logic that is specific to a very specific build variant, then you need to work with these source sets. And of course, you can also be much more fine-grained with these source sets. So as you've seen, we could also create, are we on the free or paid variant? We could also create Android test paid. We could create something like test paid debug. If you were on the release build, you could have test paid release. So you can either use or create source sets for these combinations of all different build types and product flavors, or you just have one just for the product flavor, like this one here. If you have resources just for the paid variant and you don't care about if that is now the debug, staging, or release build, then you would just use the paid source set. But yeah, guys, I know this video was a bit longer, but now I think you understand Gradle pretty well. Of course, there's still a lot more to explore with Gradle, especially how it works to configure larger Android projects. If that interests you, check the Essentials bundle down below. I will put it in the description. It's really my longest and most detailed course that I have, where you build a 6-screen running tracker app and just configure everything with Gradle, build the whole app from scratch, work with APIs, databases, work with custom UI and compose, and so on. So you will definitely learn a lot more about Gradle in that course, but I think this crash course should have given you a very good first understanding, actually quite solid understanding of what Gradle is, and should definitely help you when you run into build-related issues to better understand why these happen and where these are coming from. So thanks for watching. I will see you back in the next video. Have an amazing rest of your week. Bye-bye.